All right, geometry, here is your skill of the week for today. And it's basically the same as the day before. A lot of things similar, but there's a couple of things that are going to change just slightly. So let's take a look at this. First, it says label the sides. Well, what does that mean? We need to figure out which sides have what kind of values. We're just going to do simple values. This is half of a square here, where it's got 4 right angle corners, and 2 of those are split in half. So let's make each side of the square 1. And then to find this side here is just Pythagorean theorem, but the shortcut is going to wind up being square root of 2, because 1 squared plus 1 squared equals that question mark squared, that hypotenuse squared. So that's 2 equals the question mark squared. So square root of 2 equals the hypotenuse. Now this next one, it's similar, very similar, except it's not half a square, it's half an equilateral triangle, where all 3 of these long sides are the same. So let's call this short side 1, and then that's going to be another one there because it's split in half, just like this square was split in half. That would make the total 2. So this hypotenuse would be 2, this would be 2 down there, which we don't really need. Then if we do another Pythagorean theorem, we got 2 squared equals 1 squared plus, let's call that a squared. So 4 equals 1 squared plus, or 1, I guess, plus a squared, so 3 equals a squared, so square root of 3 equals a. So this is square root of 3. So there are the 3 sides for this one as well. All right, so when we look at something else, when it's a different size, for example this one, it's a similar triangle, and you just got to scale it up. So the first one was 1, 1, and square root of 2. Now we have 5, and remember it's half of a square. So that's going to be the same over here, and these would be 5 as well. The shortcut would be, well, then how much bigger is that? Well, if it's 5 times bigger, then it's going to be whatever these numbers were times 5. So 1 times 5. And then this piece here would be square root of 2 times 5. That's it. It's that easy. It's that fast. If you were to do Pythagorean theorem with 5 and 5, you would still come up with 5 root 2 once you simplified. For this other one, remember it's half of an equilateral triangle. So that 6 makes up this whole side, which makes each half of it 3. So we got 3 and 6. This is a 60 degree there. That's how I know it's half of an equilateral triangle. And then I could use the pattern, the Pythagorean theorem, I should say, to find this third side. But I'm going to look at the patterns here. So if I have 1 and then that's double, this is 3 and that's 6. So this is 3 times bigger. So I need to scale it up 3 times. And that means this side here is just going to be 3 times whatever that was, which was square root of 3. So 3 times square root of 3. There we go. Done. All right, now let's get to the beefy ones, the crazy ones here. Okay, so in these, the big idea is that sometimes you need to do more of an algebraic method, because you can do the patterns and you can do proportions too, but sometimes just simple algebra, putting some x's in there, will help you just as much. So let's take a look at the square. We know that the square, all 4 sides are the same, so I'm going to put an x on all 4 of those sides. And we know the diagonal here is 12. Again, I can use Pythagorean theorem, so I would say x squared plus x squared equals 12 squared. Then that would give me 2x squared equals 12, or equals 144, I guess you could say. And then we'll divide both sides by 2, and x squared will equal 72. And then if we square root that, x equals square root of 72. Now, square root of 72 does simplify, because that's actually 36 times 2. And that's something you'll find about all these kind of half of a square, 45, 45 type triangles. They always have a square root of 2 in them. And the other cool thing is that whatever other number factors out usually tends to be a perfect square. Not 100%, but usually does. So this will be 6 root 2. So this is 6 root 2 for the x, and this is 6 root 2 for this x as well. All right, so we have that. Now it's saying perimeter and area. Well, then perimeter would just be 6 root 2 plus 6 root 2 plus 12. Or you could have said 12 root 2. You could combine these first two, plus 12. Area is a little bit easier than you would think. It's just 6 root 2 times 6 root 2. Or we could go back to the square root of 72, and that's even easier. Square root of 72 times square root of 72, which is 72, and it's 1/2 base times height. So the area is equal to 1/2 base times height, and each of those was square root of 72. Square root of 72. So that's 1/2 72, which is 36. So there's our perimeter and area for the second triangle. The first one's a little bit harder, but it's very similar. We'll call this side X, or let's call it Y, just to be a little bit different, so it's not confused with the other one. And then the long side, remember, is twice that, because it's like there's two of them. So this would be 2Y. So now I'd have y squared plus 9 squared equals 2y quantity, the whole thing, squared. After doing similar algebra, you would wind up getting, let's see, you would get 3 root 3. All right, so looking at this one, if we know that 3 root 3 is y, so this is going to be 3 root 3, then this is going to be double that. So that would be 2 times 3 root 3, or 6 root 3. We could start adding things together, and then we'd have 9 root 3 plus 9 equals our perimeter. Our area would just be these two pieces multiplied by each other and then divided by 2. So the area is going to be 9 times 3 is 27. So that's 27 root 3 over 2. And then that's it. That's all you need for that one. Okay, if you need to watch it again, go ahead, and this will be posted up on YouTube.